So hi guys, it's me Deepak, and in this video I'm going to talk about stacks. So a stack is inspired from a book of stacks. Like the first book that you place in a stack is the last one to come out, and the book that you place last on the stack is the first one to come out. So it's first in, last out, or last in, first out. So what is stack? Stack is a linear data structure which follows a particular order: first in, last in, first out. That's simple. Now let's talk about why are we studying stacks. So what is our motivation behind learning stacks? So the first motivation will be infix to postfix or prefix expression. Postfix or prefix expression. In short, you have a equation like, let's say, a times b. You can write it as ab multiply. Let's talk about string reversal. So how it can help in string reversal? So if you see a book of stacks, you see that if you're first in, last out. So let's see with a simple example. We push the character one by one into the stack and then pop them one by one. So let's say a word, literally a word, W-O-R-D. I put it into a stack. So W, then O, then R, and then D. Now if I pop it, like I will have a D first, then R, then O, and then W. So technically my string is reversed. So from W-O-R-D to D-R-O-W. So you can see it helps in string reversal. Let's talk about third thing, backtracking. How it can help me with backtracking? You might ask. So let's say I'm solving a puzzle, or I'm solving a maze, let's say. So I end up let's say I try a path and the path lead to a dead end, and I want to backtrack back to that point, to the initial point. So string can help in that. The stacks can help in that. Now let's see some of the basic operations of stack. So the first one will be push, to add an item into the stack, and if the stack is full, then it's an overflow condition, stack overflow. Let's talk about second, that is pop, to remove an item from a stack, and if the stack is empty, it's said to be underflow condition. And note, the popping will the popping will occur in reverse order. Third thing is empty. Check if the stack is empty or not, and if it's empty, return true, and if it's not, then false. So let's check the code. So we have a C++ code. I'm importing all the libraries bit c++.h. if you don't know that. They're using space name std, and let's say int main. That's our driver code. So I will return 0 basic. I have a struct node. S is smaller here, so struct node. I will have int, for obviously int I'm storing data here, and a node pointer next. If we store the address of the next node, in this case the previous. Let's see our struct root, which will hold the position of the highest node. So struct node at this point is null. I'll pass the address of this root in the push as well as the data. So let's create a push function. I'll pass and root and the null and the data, sorry. Let's say 10. Similarly, I'll have push address and root 20, again push root 30. Now let's create the function. So I have node pointer, let's say root, and I'm not very creative, so int data, and I'm listening to songs. It keeps me motivated. So node pointer temp equals new node. I'll pass a data because I'll create a new node. So I'll have a node pointer new node. I'll pass int data. It will have. So let's create let's create temporary node. So I'll have node pointer temp, and it will be equal to new and node with two curly braces. This is node function. If you know how you create a new node, you must have learned it somewhere. So let's move on. Let's have a temp. We will store the temp slash. You can have, there's another way of writing temp to data equal data, but this is an easier version. So temp next, I'm storing it to null. The address of the next one null, and then I will be returning that temporary node, and I will be storing it into this temporary node. Temporary next equal pointer root. So I will store in the address of this root in the next one, in the temporary next. Then I'll print out that. Then I'll print out data that this is pushed into the stack. Let's change the track. So temp next equal pointer root, and I'll be switching the root to this root. So now the root has become this stack, this position in the stack, and it's storing the address of the previous root. So just keep that in mind, that the previous one address is in the new node. Just keep like nodes and you might understand it. Like, I don't know any better way to explain this right now. So let's pop it. So you know the popping occur in reverse order. So the latest stack that has been pushed will be popped. That means the 31 will be popped first, then 20, and then 10. So I'll pass in the root because that's the highest one, and I will check. So in this case we know that the stack is not empty, but there are cases when stack is not empty. So let's have a if condition. So if it's not empty, then int is empty. Then let's create a function int node root, and return false if it's empty, return true, and if it's empty, then print that stack is empty. You cannot pop anything unless you don't have anything. I think it's underflow condition, what you say. I might edit this out. So let's have the pop function. I'll create a temporary. I store the root there for some reason. Then I'll have int pop item. So I'll be storing the data of this. So I'll be storing the data that I am popping out, like I'm storing 30 here, so popped, and then I'll be storing the root address to the next root. So now the node will be dropped to one step. So you know that we switch the nodes to the next one, but here we're storing it to the previous one. So let's say we have stacks of books. So 10 will be if I remove 10, then the most top one will be 9 now. And I'm returning the number, so I can print it like this is out of the stack now. So there are some mistakes here, like pointer root, is empty should have a is empty should have a pointer root, not root. So we have to correct this. And there's one more mistake, like the s should be small on the top, as I have mentioned earlier. So let's fix this. So let's copy it and run it on an online compiler, because why not? Basically my code blocks is not running for some reason, that's why. So as you can see, we have inserted the stacks. Now if you see everything is running, no fault is there. So guys, if you like this video, comment in the comment section, like the video, subscribe, share it with your friends.